No, thank you very much, Dimitar. I'm very honored to be one of the speakers for today. I also was really very excited about the previous speakers, and I would like to contribute a little bit about the concepts and practical examples of transdisciplinarity from my German perspective. First, let me ask you, can you all see my presentation?
Yes, we can see.
Okay, fine. So I would like to start out as saying that we're witnessing today three major global transformations. And these three major global transformations are single part of the context in which transdisciplinary science is embedded. The first one is the transformation towards a globalized world. But at the same time, we see, of course, a lot of movements towards renationalization, even towards building new empires. The Ukraine war was already mentioned. But there is a tension between a globalized economy worldwide and a retribalization of policies. So that's part of the conditions under which we operate. The second one is that we are in a major transformation into a digital world, specifically with artificial intelligence. It's been a major element, and I think Professor Oyomada mentions this as a part of a very important element of technical innovation that changes our life. It changes the way that we are governed. It changes the way that we relate to each other, and so that's also a very important one. And the third one is what I could call sustainabilization. That is a movement towards a more sustainable life world, a more sustainable economy, more sustainable civil society with a strong focus on climate protection. Now, what's important is that all these three are interacting and sometimes are in synergy with each other, but very often they're also in opposition to each other. And I think one of the things in terms of transdisciplinary science is really to make sure that we understand the interaction between these three major transformations that are occurring at the same time. Now, in addition to the transformation, we have what we call unintended side effects. So those are kind of impacts that go along with those transformations that are basically at least desired by a large amount of people. So we have global environmental changes that nobody likes, but it's a part of the modernization process. That's climate, biodiversity, pollution, environmental health, and many others, but those are the ones that are most prominent. We can also see that there's an increase of vulnerability with respect to the interactions between technological, social, and natural risks. When we talk about Fukushima in Japan, you can see that a natural hazard then went into a big technological disaster. So we have these kind of interactions, which today we call polycrisis. Third thing, we see that we have still a strong tendency towards urbanization, major demographic changes, migration all over the world, partly due to climate change, and different concepts of land use planning, specifically taking away natural parts in order to make them more feasible for human development. We foresee governance deficits, first corruption, renationalization, we just mentioned that, authoritative, autocratic leadership till even neo-imperialism. So those are things that we hope we could have left to the 20th or 19th century, but they are reappearing. It's just like the Hydra that always comes up again with its bad services. And of course, the last thing which I think I would like to mention is severe equity problems with respect to opportunities, income distribution, and of course, vulnerabilities. So this is a part of our world. As I said, it's been characterized by polycrisis, also by a lot of opportunities. I don't want to miss out that there are many opportunities out there, but it's important that we take the opportunities and reduce the risks and do this on a global, but also on a local level. And that's where I think transdisciplinary science is pretty important. So the crucial question is, what do these trends imply for the relationship between science and society? And I would really focus a little bit more on science and research, and my co-speaker, Daniel, will then go more into teaching and education in terms of university education. Now, we have major challenges in terms of this relationship between science and society. There are major increases in scientific studies and analysis, specifically on climate change, on other ecological challenges, but also the other social and political challenges that I pointed out. But we can see not a lot of impact in terms of success of sustainability, climate protection, or resilient structural changes. So what we can see is we have a lot of very good analysis, and some of them were mentioned actually by the previous speakers, OECD reports and many others, but the impacts are fairly weak. And I think that's something we need to think about. Why is it that we do have a lot of good knowledge? We know what to do, but we don't do it. Secondly, we have a plurality of knowledge claim. Science is not the only knowledge provider that counts. That's specifically true for all the challenges that I pointed out. We need indigenous knowledge, we need experiential knowledge. All of that is very important. And the systematic knowledge of science is very crucial, but it is not sufficient. And I think that's one of the things which also is strongly in favor of transdisciplinary science approaches. There are a lot of missing bridges between knowledge and action, which was also pointed out before. We do know a lot, but we don't do accordingly or do not initiate the actions that are needed. And there are a lack of convincing concepts for transformative and transdisciplinary research. We've seen now quite a few examples in Japan, and I want to congratulate you for these very interesting examples, but we're still lacking, I think, a good, clear concept. Now, I've tried to propose a transdisciplinary concept of science that include three major parts. And I think we're now just focusing on science, not on the other knowledge carriers that I had already pointed out. And there are three types of science that I think are extremely important for transdisciplinary approaches. The first one, which I would call classic research, is the research that we are familiar with when we talk about university. It's curiosity-driven. We want to know something that we don't know. It is characterized by methodological rigor. We really want to be sure that we are getting closer to the truth and that we do find something that is beyond doubt. And we have a lot of open questions that we want to answer, but we don't know exactly the direction in which the answers will go. This is a part of the driver of university research, is a driver of progress and change in societies. And it's certainly something where we do need, but it's again not sufficient. Secondly, we have what we call goal-oriented investigations, and they're becoming more and more important, specifically in the interface between science and policymaking. So we ask scientists to develop coherent strategies to reach a predefined objective or a set of objectives, including the assessment of unintended consequences. So that's something we want to reach climate neutral energy supply in 2050. So we ask scientists, what is the best strategy? What is the best scenario? How to reach that goal? And what are the kind of consequences that we need to take into account when we follow this strategy? Do we have several strategies? Is there a choice that we can make? How many trade-offs do we have to make when we are following or pursuing one of these strategies? But the main thing is it's not classic curiosity-driven research. It is a research that is driven by a specific objective. You want to reach, for example, climate neutrality. We want to reach more biodiversity. We want to reach a better governance structure. And what is scientifically the best way to do it? And here again, it's very clear that scientific knowledge is very important to do that, specific to find out about unintended consequences, but it's not sufficient. And the last one, and which is very important for, for transdisciplinary science, what I call catalytic expertise. And catalytic expertise is really an expertise on process. So we are trying to analyze, design, and facilitate processes that initiate constructive and productive learning platforms among and between different knowledge camps, interest groups, and value orientations. I think the various value orientations just mentioned by Professor Oyamada, and of course also design, a second point, and thirdly, the inter-actor performance, all of that is part of the catalytic expertise. It is about social scientists specifically to design processes that can help us to bridge the gap between knowledge and action. And we need to have better ways to make decisions. We need better ways to make prudent judgments. And we need better ways to transform what we know into societal actions, even if we have plural values and plural interests. That is what we call catalytic expertise. Now, all of these three are, in my view, major components of transdisciplinary approaches. We need some results of classic research to be sure that we know what we're talking about. We need goal-oriented strategies so we know what kind of options we have. And we need the kind of processes that help us to make better decisions about these options and to implement them in the local, in the regional, in the national, and in the global arena. This leads to 4 functions of scientific evidence that I would like to highlight. Specifically, the classic science, curiosity-driven science, is there to enlighten people, to inform policymakers about complex relationships. I think that's extremely important. Very often we know that there are some prominent consequences that policymakers are concerned about, and they miss out, ignore, or even deny consequences that are associated with their decisions. We need orientation from science, passing assistance for foresight, vision, and planning, so that people can also understand what are we trying to accomplish, what are the goals, and then we can build the strategies. And that's number 3, that we have the goals, we have the orientation, but now we need to elicit strategies. We need to assess these strategies, and we have to find out what are the trade-offs and how can we prioritize when we have conflicting goals. And then lastly is to co-create solutions. And co-creation was also mentioned several times. That is, we come together with scientists, policymakers, stakeholders to develop kind of new insights from Enlightenment orientation and predefined strategies, and develop a kind of implementation policy together with change agents who can help us to really implement what we need to have. So this is a kind of the environment in which transdisciplinary science can take place. So what we need is an integrated approach. Policymakers all over the world, whether it's Japan and Germany or Europe, need scientific support in all 4 substantive fields: enlightenment, orientation, strategy, and co-creation. There are different requirements in terms of special discourses. They're not just one discourse that can do all of this. So we need catalytic science to design the most appropriate discourse, analytic discourse, deliberative discourse, that all have their own normative rules and implementation criteria, but they need to be designed to have a synergy among the various stakeholders and between the various topics that we're dealing with. Complex problems demand combinations of discourses. They may start as epistemic discourse, what's true, what do we know? They may lead to orientation, what do we want to have? Then go to strategy discourses, how can we get there? And might end up as an exercise in co-creation. What all can we do? What can we contribute to reach the goal that we all want to acquire? Now, I was also asked to give you some case studies, and I will do that now. I have 3 case studies here in which we try to implement this kind of transdisciplinary concept. The first one is a little older already, but it's one that has been now completed. That's why I selected it. This was a climate protection plan for the state of Baden-Württemberg. For those who are not familiar with Germany, this is one of the German states, or similar to Japanese prefectures. It has around 10 million people, so it's a fairly large state in Germany. And it's fairly industrialized. All the big car manufacturers are basically located in the state of Baden-Württemberg. This was a transdisciplinary approach. There was a climate protection goals. They were defined by the state government, net zero for 2050. Then in an analytic tool. So that's more like as a classic expertise. Scientific experts were asked to provide roadmaps with strategies and measures to reach net zero, to reach that goal. So it's also a kind of, developing goal-oriented strategies. Then 7 round tables were established for stakeholders. So these tables were initiated in all of Baden-Württemberg, the cities, and also in the rural areas. And they were asked to select measures, to comment on them, and to prioritize them. In addition, we had asked 4 citizen forums, random selection. So those were citizens just selected randomly, and they were asked the same thing, to go through these strategies and to select, comment, and prioritize measures. We also added a virtual citizen forum. Those are volunteers who also had the same point. So everybody who wanted to comment, wanted to prioritize, wanted to select. This was, of course, a forum that was well facilitated, but it was one in which everybody who wanted to be part of it could attach himself or herself to it. And in the end, it was about 300 people that actively participated in this virtual citizen forum. And in the end, we had one joint forum, which was formed from all bodies to reach conclusive recommendations. Here you can see the stakeholder groups. We had one on electricity, one on private consumption, one on industrial applications, one on heat productions, one on mobility, one on the public sector, what they can do in terms of planning, and also, of course, for its own services in agriculture and food. And each of these stakeholder groups had stakeholders who were kind of organized groups in society that dealt either with electricity, private consumption, and so on. So those were the stakeholder groups. Then we had the citizen groups in different areas of Baden-Württemberg. You can see 1, 2, 3, 4, 5, and one online participation, as I said before. And these citizen groups also dealt not with all the ones, for example, industrial applications, did not ask the citizen groups to talk about, but about electricity, private consumption, mobility, and agriculture and food. What were the results? There were 110 recommendations for reaching the climate protection goal. There were a lot of interaction between science, so basically goal-oriented. We had 3 scientific institutes involved in the exercise, and there was an action between stakeholders, but also between the randomly selected citizens and the virtual volunteers. So we try to have a good orientated or good facilitated discourse between these 4 different constituencies. We had an integration board with all of them, and that was really interesting. It was very difficult to get an integration among all these different groups, but they ended up with 46 consensual recommendations. So ones that they all agreed that was good. And a second point, which was very interesting here, was we had 28 recommendations that were highly supported by one group, and the others were indifferent. So they said, okay, well, if they like it, we don't think about it as very important, but if they like it, let's do it. And the politicians later told us that those were the most important ones, because they could see, they could feed these kind of measures into the constituencies that they felt were very important for them and not violating the values of others. So they were kind of, because the others were indifferent, you could do even interest-driven policies without really being trapped into a zero-sum game. There were 12 contested and 25 highly contested recommendations. So their politicians or policymakers had to say, okay, do we leave them out or shall we still do them? But then have, of course, opposition. There was a validation by expert groups with respect to effectiveness and efficiency. That was very important. Each measurement was then assessed by an expert group whether they would actually bring a substantial increase of climate protection to the state. And the state governments released a protection plan honoring most of the recommendations, specifically the 46 consensual and the 28 party supported recommendation. So this was a major success. Actually, this exercise won the first prize for citizen participation in a national competition. Let me go to case study number 2. That's the German National Citizen Assembly 2022, again on climate change. Here, our institute was not involved in organize the whole thing, but organizing the analytic part of the scientific input. So we had 2 components here, an analytic and a deliberative component. The analytic component was we had experts' assessment on the effects of different policies and measures on whether they would actually bring the success that we wanted to have. There was an establishment of a scientific committee to monitor the process and to provide analytic input into the deliberative body. And there was an establishment of a core group of scientists to assist citizens in making evidence-based judgments. So we always had people from that analytic group. There were around 22 scientists from all disciplines that were actually accompanying the deliberative process. The deliberative component was based on a random selection. 168 citizens of Germany, corrected for each education region, were selected. It's not a representative sample, I have to say that, but it's very heterogeneous and it does somehow represent most of the groups in Germany. There were 4 major topics: mobility, heating system, consumption, and food. And due to corona, it was all done online over a period of 6 weeks. The process of deliberation, how was it done? We had input by experts, as I said, that was part of our responsibility. There were question and answer periods, small groups that were facilitated by professional moderators, all online, but we also had small groups without moderation, where people just organized themselves, and all the results were reported to plenary sessions and then documented. Then there were evaluation sessions. Policies and measures were discussed with respect to their mutual advantages and disadvantages. So everybody had a list of plus and minus, and then they could add to the list. Experts assess the effectiveness of each suggested policy and measure. Again, just like in the Baden-Württemberg case, that was crucial. People sometimes had the feeling, well, if I turn off the light, this will lead us to climate neutrality, which of course doesn't make any major difference. So we had to tell them what was really effective and what was not, and how much effective. And a lot of people were quite disillusioned when they found out that some of the things that they felt were very effective did not make much of a difference in terms of climate protection. Small groups made suggestions for final discussions. That was also important, that we had a really deliberative process here. And in the end, citizens voted. There was a threshold. Nothing was adopted that didn't have at least 75% approval. Results, clear decision to keep the Paris Agreement. That was not so surprising because it's law. Phase out of coal before 2035, because that's what the government wanted to do. They felt it should be done earlier. It was clear that they wanted to exchange of home heating cooling system to accommodate green energy sources. However, and that later on was a part in which the German government failed, they wanted to make sure that poor people were compensated. And there was a lot of emphasis on equity, and that's also part of the conflict. And there was a lot of emphasis on public transportation, bicycle routes, but there was no support for banning combustion vehicles. A conflict, additional costs should be taken up by tax money. Well, that's always an easy way out, sorry, but that was something that came out as this deliberation. Rich people should pay more for the transformations. And even the rich people in the deliberative body agreed to that. And preference for economic incentive subsidies and governmental role models, not so much prohibitions or carbon pricing. So that was the kind of results, and you can say, well, these results are kind of motherhood and pie, but nevertheless, I think many of them were quite clear and were given to the government. What were the implementation? And you can see government and parliament felt supported. Most stakeholder groups endorsed the recommendations, few did not. But there were also skeptical views about acceptance in the broader population, that these people were elected to be kind of role model citizens, and a mixed media evaluation, positive and negative. The impacts, the government noticed that they need to put a strong emphasis on justice and fairness. But the program that they developed did not convince the skeptical public, what to say, but they were alerted to this. There was a law for exchanging heat systems which failed more or less due to public protest. So in that sense, what the citizens had said, we want to have exchanging heat system, but we need government assistance, was not convincingly conveyed to the electorate. And there was a polarization with respect to green energy plants, and that increased over the last 2 years. Now, looking at the time, I think I would just drop the case study number 3. We can look at that in the, and I can share with you the presentation. Let me go to my conclusions. In transdisciplinary science, there's a new role for science, and there's focus on 3 major scientific concepts. We need a good combination, a good synergy between curiosity-driven classic concept, which is the one that we pursue in universities all over the world. We need goal-oriented strategic instrumental concept to reach predefined goals. And we need process-oriented catalytic concept that help us design the policy process that bridge the gap between knowledge and action. There's a need for an integrated governance approach, providing understanding, orientation, strategies, and co-production of knowledge and action. All of that is part of the transdisciplinary process. And the 3 case studies, I only showed you 2 this time, showed in principle that transdisciplinary design does work. They were all more or less successful, but it does depend on topic, actors, and political context, how much success they will have. It's not clear that they will always be successful. I could also give you some example where it didn't work, but nevertheless, I think that we could show that if we keep that kind of synergy between curiosity-driven, goal-oriented, process-oriented science, that we can really contribute to the transformation. So this is my presentation. Sorry that took a little longer, but I hope I could give you a little bit of a background of what happened in Germany and what kind of concepts we are pursuing here.